Hello everyone and welcome back to another video. So in this video I'll be going over minimum number of refueling stops. So in this problem I'm just going to simplify essentially what we need to do in this problem. If you want to read the problem statement, I'll provide a link to the problem in the description. But essentially in this problem what we need to do is we're given an integer of how much fuel we start with, and we want to make this number here greater than or equal to the target, because this is how much fuel that we will need. And of course, and what we need to output is how many refuelings we need to do. So of course in this example, our starting fuel is already greater than or equal to target, so we know we don't need to refuel, so we can output 0. As you can see, that's their explanation. And to make this a little more challenging, because of course if it was that simple we could just do a simple comparison, we are also given an array of gas stations or fueling stations. So every array inside of this array will represent a station where the first number in it, this is how far the station is. So this means you need 10 units of gas to be able to reach this station. And this number here represents how much gas you can get from that station. So in their example, they start with 10 units of fuel. They know they cannot reach all the way to 100, but they can reach the station that's 10 units away and get that refueling of 60. And so after adding that, they'll essentially have a starting fuel of 70, because we know it's possible for them to move like 70 units or like gain 70 units of fuel. Yeah. So essentially we need to output the least number of refuelings that we need to do to have enough fuel to reach the target. So to make start fuel greater than or equal to the target. If that was a little confusing, you can always just go read through the problem description through the link in the description. But yeah, so now I'll be going into the explanation of the solution. So first of all, we know that stations is sorted based on which stations are closest. So we know this 0th number, that's going to be this first number here. That's how far the station is from our starting point. So we know the stations are already sorted, so we don't need to worry about that. And yeah, so what we can essentially do is just be greedy. So we can pretend, let's just say this is our road. So we start at 0, and let's say we want to reach 100, that's our target. And let's say we start with 50 gallons of gas. So 50 liters of gas. So we know, let's just say there's a gas station here at 20 and a gas station here at 40. And so we know that we first of all, we know that we cannot reach the end because 50 is less than 100. So we know we can access these two gas stations. So we can simply choose whichever gas station will give us more fuel. So if this gas station gives us 60 gas and this gas station gives us like 20, well, obviously we will choose to refuel at this gas station, because then essentially, let's just say this has 60 liters of gas. Essentially, then we will have 50 plus 60. That's the total distance we can travel. Because if you think about it, we'll spend 20 units of gas getting to here, so we'll have 30 gas left. Add 60 to it, that's 90. So we'll have 90 units of gas, and since we already moved 20, we'll essentially be able to get to 110, and that just simplifies to 50 plus 60, because 50 plus 60 is also 110. So yeah, so we know which gas stations we can reach, and we can simply choose the best one that gives us the highest chance of being able to make it to the end, since we want to use the least amount of refueling stops. So this was a fairly simple case, but if we look at it from a more complicated case, let's just say this is really far away, so like it's 1,000 away. So we know we start with 50, so we know we can either stop at this gas station or this one. So we essentially move all the way to 50. This is how you can think about it. So we move all the way to 50. We look back and we see which gas stations we could have stopped at, and we just say, let's just pretend we stopped at the best gas station. So we'd essentially say we stopped at this one, we cross this gas station out because we stopped at it already, and add however much gas we have to our total. So now we know we can get to 110. So we use up all our gas again. Let's say there's a couple more stations here, like 30. Let's say this at position number 60, and it has 10 units of gas. And let's just say we have another station here. So this is 110. 110. Let's just say we have another station here. It doesn't really matter. So after we run out of gas again, we can simply look back and think, hey, we could have stopped at this station, or this station, and we choose the best station again. And yeah, so let's just say, for example, we chose this station since it had the most gas. We can cross that out um, and use up all that gas again and see if we add any more gas stations. And uh, let's just say we run out of gas again. We know we could have got more gas from this station here, this station, or this station, and just keep on doing that. Choose the best gas station that we could have potentially stopped at and say that we refuel there. So um, the way we implement this really easily is we can simply have a max heap that keeps track of the gas station which currently is the most promising. So if we move from here all the way to here, we'll know that we could have stopped at any gas station in between. So we just need to remember that. We just need to remember whichever gas station is the most promising. Let's say this one has the most gas. We just pretend we stop there and keep on going. Then we cross this out. Then we know once we run out of gas again, let's just say we run out of gas again, we know, hey, we could have stopped at any of these gas stations before or any new ones we ran into, and then we choose the one that'll give us the best chance of making it to the end. So we choose the one with the most gas again. So I think it's a fairly intuitive solution actually, and let's look at how we implement this. So first of all, we can just make a priority queue, and this will represent the gas stations we can stop at. And we can just make it a max heap by giving it this expression, which essentially makes it so when you take in A and B, a regular min heap does this. It does A minus B, but because we do B minus A here, that'll just reverse the order of how um, things are sorted inside of this queue. So the queue will actually uh, save the largest numbers, which we want because we want to add the most gas every time. And so we'll have a variable keeping track of how many refuels we've done, and an integer that'll just help us loop through our array of stations. So this outer while loop is pretty explanatory. So while we cannot reach the target, so we don't have enough gas to go all the way to the end, then we want to look at which gas stations we can stop at. So this loop here does that. So while we can stop at that station, we will add that station to the stations we can stop at and increment our current station. So our queue here, fuel, will hold these integers here representing how much gas we could have gotten if we stopped at those stations we could have stopped at. So this loop here just checks which stations we can use to refuel. And if we cannot refuel at any stations, we know it's impossible, so we can return -1. Because we cannot reach the target here, and we cannot refuel, so we return -1, as given in their problem statement right here. And otherwise, we will just add the best fuel stop at the gas station with the most fuel and add one to refuels. So this queue here will essentially remove the best gas station, but it'll still keep all the other ones, because that way, whenever we run out of gas again, we can look back and say, hey, we had a potential to stop at any of these gas stations before or after this one that we did. We just didn't need to yet. So then our queue will always hold the best gas station that we could have used. And obviously, if we run out of gas, we'll want to use it. So we add that to our fuel and add one to our refuels and then loop again. So obviously, if now start fuel is greater than target, we know we can reach it. So we can just, we won't go into this loop and we can just return however many refuels we had to use. Otherwise, we do that process over again where we go here and run out of fuel, and then we look back and say, we could have stopped here, here, here. We already stopped here, so we cross that out, and then any other ones, and choose the best gas station that we could have stopped at. And that we choose it again, and we keep on going. And yeah, so this is the how to implement the solution for the problem. And if we submit it, it gets accepted. And the runtime of this should be O of n log n, I would believe, because we're essentially looping through the entire array of stations, and adding a station to this max heap would be a log n operation. And because of how small this length is, this will easily run within the time constraints. So that's about it for this video. Thank you very much for watching, and I'll see you guys later.